Welcome to a lecture at the Department for Architecture, Theory and Philosophy of Techniques at Vienna University of Technology. My name is Karla Saldana. I'm an architect and researcher currently doing a PhD at the chair of Professor Ludger Hofstadt at ETH Zurich. Today, I am going to talk about architecture and natural disasters with my presentation entitled Event Protocol: Enhancing Disaster Response with Architectonic Capabilities by Leveraging Machine and Human Intelligence Interplay. Most of the concepts I'm going to introduce here were developed during the mnemonics meetings, which are organized jointly by Professor Vera Bühlmann, Professor Ludger Hofstadt, and Dr. Elias Afilis. So, we live in a world where natural disasters are constant, and comprehending their impact depends on how we understand the world itself. The world, our planet, is a complex and many times an inaccessible object that thus its complexity can only be described by abstractions of it. Through time, we have created instruments to describe the world, such as maps and models. Those instruments are abstractions that reveal part of its complexity synthetically and simplistically. For the sake of experimentation, I invite you to forget the already loaded meaning of the words map and models and exercise a new approach to them. In 1931, Alfred Korzybski introduced the notion that the map is not the territory. For Korzybski, the territory suggests a specific whole, the world. Hence, I will operate with the notion the map is not the world. According to Korzybski, an ideal map will contain the map of the map of the map endlessly. For him, a map will never capture the world entirely because it's always an abstraction that freezes one interpretation. In the relation between the world and a map, I propose to add the notion of a model. So, model is a specific render of the already biased map of the world. To illustrate in more detail the differences between a map and a model, let us draw our attention to two examples in history. The first being Ptolemy's book, Geography, a treatise on cartography based on a lost atlas by Marinus of Tyre with evidence from sailors. The book contains a collection of numbers known as coordinates that are related to each other to describe the world at that time. The second example comes from the 15th century by Alberti's second treatise on mathematical foundations, Descriptio Urbis Romae. Alberti was fascinated by Ptolemy's book Geography and hoped to provide an equally rigorous and quantitative framework to describe Rome. In this book, Alberti collected a series of tables listing numerical polar coordinates. An interesting fact is that for Alberti, the word descriptio was used to denotate a map, or what I call a collection of numbers. What is interesting in both treatises is that the first book in the case of Ptolemy and the first chapter in the case of Alberti are dedicated to the instrument used to access the world and abstract its complexity. Both instruments allow the creation of an early digital data. I will argue that the intention of the authors to develop such instruments was to allow anyone to utilize them for modeling. In this work, modeling is considered as an action that enables us to go from digital data, or what I call a map, to the creation of information, or what I call a model. Another interesting symmetry between both authors is that they have a strong presence of a circular manner, placing the human in the center. To continue with their treatise, the following chapters of their books were mainly about their maps, or these lists of numbers. So I will say a map abstracts the world with any numerical representation to create categories and relations. A map resembles facts of the world of any dimension without rendering or representing its data. It's one step before the representation. And every representation or projection of their maps is what I call a model. Model is an abstraction that deals with projections, representations, and perspectives. The term model comes from the Latin word modus, meaning a particular manner, and from model, meaning to measure. By using the word model, I refer to an action that both abstracts and measures. Therefore, a model projects by measuring dimensions of a map into a reduced geometrical space. A model is always a particular render of the already partial map of reality. Nowadays, we have new instruments, new maps, and new models. I will say today's instrument is artificial intelligence. Today's maps is this digital data, or this big data that lives in the digital world or internet. And today's models are any specific representation of this digital data. Currently, the traditional modeling paradigm comes from the mathematics of set theory. However, in 2017, the mathematician and physicist Elias Safiris proposed to change the former modeling paradigm with one based on the mathematics of category theory. Safiris stressed that in nature we do not have access directly to the things that we would like to model because they are always encoded in geometric structures. To access the complexity of nature, he introduced the natural communication model, a cryptographic model that, by reducing complexity, creates new information. In the simplest case, the natural communication model contains an encoding bridge and a decoding bridge, which are necessary for establishing communication between the two levels, geometry and arithmetic. And the communication between the two domains is in constant movement around the notion of nature. To return to the map and model, we see that both abstractions allow us to grasp something beyond reach, the world. However, because of their capabilities, they are from different natures, similar to modeling and mapping that enables the transition between the map and the model continuously. So to relate them, I suggest using the natural communication model proposed by Safiris. We can see that a model can be placed in the domain of geometry, since it is a specific render from a map, which comes from the domain of arithmetics. And in order to embrace the obstacle of abstracting the world and communicate these two domains, I propose to build an encoding bridge by machine intelligence in charge of mapping, and the inverse decoding bridge by intelligent humans in charge of modeling. What is important about the natural communication model is that these four concepts are in movement around the obstacle of abstracting the world. Yet, if the obstacle changes, the concept around will do as well. I want to give a quick comment on the rhetoric use of intelligent humans. It's just simply to emphasize the inversion to the term machine intelligence. So when replacing model and map to event protocols and map of events, the natural communication model is adapted to the scenario of natural disasters, allowing the concepts to have a particular articulation in motion around the notion of natural disasters. And in the following slides, I will elaborate in more details the characteristics of each of these concepts. So, event protocol. My attempt to operate with the term protocol acknowledges that the term is often used by humanitarian organizations to address specific or certain procedures that are applied in specific assessments for disaster response. However, I will add an extra layer of meaning from the original one and utilize it to fit the natural communication model as a descriptor of the capabilities of the event protocols domain. The word protocol comes from the Greek word protokolon, which describes the first sheet glued onto a manuscript. The word proto comes from protos, meaning first, and kol from kola, meaning glue. With this in mind, we can think of a protocol as the first glue that joins elements. Further etymological research extends the term's meaning towards an agreement, code, contract, compact, etc. In this word, the use of the term protocol unites both Greek and modern definition, considering a protocol a compact that joins or glues indexes, and is from the same category as a model. Map of events. In history, events are narrated in a total order. Therefore, they can easily fit into a line or a timeline. In the last decades, most of the studies dealing with events operated with a linear manifestation of events, for example, event evolution, event correlation, or event sourcing. However, due to quantum mechanics, we know that every action and reaction in nature cannot assure linearity, but rather non-linearity. Following this line of thought, Safiris expressed that because of non-linearity, events in the far past can be related to today's event, because we can find shared properties that connect them, and he calls this sculpting time. Sculpting time is formulated under the same, let's say, characteristics of the natural communication model. Hence, I will utilize its capabilities in the map of events domain, where natural disaster events are related through their invariances or shared properties rather than their historical occurrences. Currently, machine intelligence is built by a twofold approach. One that seeks to reduce human intelligence into symbolic manipulation, and the other one that tries to mimic the models of natural behavior and create a mathematical model for it. In both cases, machine intelligence has seen as a problem-solving tool attuned to a specific set of problems. However, from my point of view, instead of solving problems, machine intelligence dissolves them. With the current abundance of data and machine intelligence algorithms, anything becomes available and therefore also becomes dissolvable. Because of its capabilities, I argue that machine intelligence does mapping to arrive at the domain of arithmetics from the domain of geometry, which is to say that machine intelligence can transform any geometrical representation to a numerical one. Intelligent humans. René Descartes, in his book A Discourse of a Method for the Well-Guiding of Reason, sets the path to define an intelligent human as the one able to reason rather than how educated he or she is. Descartes does not refer to an educated man, but to an intelligent one. According to him, we are all intelligent because we can reason and understand. He elaborates this idea by writing, "It is almost impossible that our judgment could be so clear or so solid as it might have been had we had the entire use of our reason from the time of our birth. and been always guided by it alone. Because of our capabilities, we humans can perform the task of modeling, to give form. Modeling is intrinsic from our human ability, whereas machines always encounter problems with jobs to which reason and creation are required. Intelligent humans deprived of computational power can articulate complex problems, reasoning, understanding, and taking ethical stances. Inversely, machine intelligence is fast, computationally powerful, and grows exponentially in processing, storage, and communication. With the lack of one, the other will only produce a halfway product. Hence, these two forms of intelligence have specific assets and capabilities that, if utilized together as one complement to the other, will allow us to face the biggest challenges of our era. As I explained before, each concept, event protocol, map of events, machine intelligence, and intelligent humans have specific characteristics, and by being joined together in this iterative cyclical manner, they define an instrument. And this instrument I call a mediality. So a general mediality is the ability to become a channel of communication or to find a middle or common ground. Therefore, the mediality I propose is a space where the plenty exists, moves, organizes, and grows, yet can articulate specific formations derived from the spectrum of possibilities. This mediality will adapt to many users and their various modalities of usage to facilitate individual responses to natural disasters. The characteristics of the mediality is that while containing compilation of big data, still can produce specific articulations depending on the user's concern. This proposed mediality is rendered in an experiment that aims to exemplify the communication among these previously mentioned concepts. But after natural disasters, two processes happen. We produce a massive amount of data from social media, news, satellite imagery, and NGOs, and we developed several studies using the state-of-the-art technologies for disaster response. However, the produced knowledge and data are not commonly used in the scenario of an actual event because information arrives too late to influence decision-making. Hence, the question I'm trying to address is how can we quickly navigate this abundance of natural disaster-related data to find information relevant to enhance the involvement of particular disciplines in disaster response. So to answer this question, I planned to produce a mock-up to showcase the communication between map of events and event protocols to facilitate disaster response. So in this mock-up, I propose to characterize natural disaster events by any free available data of its occurrence. This data will be transformed by machine intelligence into its numerical representation to create a map of events. This map will contain all the events from the last 10 years characterized by n dimensions. The map of events will allow a user to reconstruct what the event was depending on how he or she chooses to characterize it. For example, 1 dimension, geographic location. 2 dimensions, geographic location and period of occurrence. 3 dimensions, geographic location, period of occurrence, and humanitarian responses. Or n dimensions, any available data of its occurrence. When a new event enters the map, it transforms the map into a model by rendering a specific interest. This model is an event protocol, where correlation among events can be found by not defining or fixing 1 dimension, but letting all the selected dimensions to be considered. The event protocol is a two-dimensional representation of the map of events that provides a spectrum of possible assessment and logistic decisions for disaster response. A key feature is that there can be as many event protocols as the question the user has. The event protocol aims to inform architects to have a clear and agile response to natural disasters. So I'm proposing that architects should be involved in the early stages of disaster response, not only designing unique artifacts, but also creating a massive set of data and deriving architectonical interventions that take considerations of the many indexes around the natural disaster. So, by using this modality that I just described to you, I addressed three questions, creating three protocols. The first event protocol deals with many narratives in disaster response, which create a state of disinformation and chaos, especially in rapid building safety assessments. In this experiment, the map of events shapes to consider 10,000 academic writing in the field of rapid building safety assessments to be transformed into an event protocol where information is filtered and prioritized regarding a specific interest in responding to a particular disaster-related concern. The outcome of this event protocol is a collection of academic writing that suggests tools and approaches to respond to a specific problem. This event protocol works with aerial imagery from before and after a natural disaster. The map of events was categorized based on a shared similar pattern found in the change between the both stages and statistical data of the disaster itself. The resulting event protocol can be considered as a catalog of change that can serve as a predictor for future cases to foresee possible changes in a new case study to continue with the architectural planning process that mitigates its possible impacts. And finally, an event protocol that worked with collected data of humanitarian responses, the magnitude of the event, people affected, demographic information, and the analysis of the built environment to result in an event protocol that finds an event similar to an actual case and predicts the possible results based on the previously learned lessons. So these three examples demonstrated how one, by applying architectural concepts to the field of disaster response, can result in specific models that resolve some problems depending on the user's question. In this way, enhancing disaster response with architectonic capabilities by leveraging machine and human intelligence interplay. But I hope you enjoyed this lecture, and I hope to see you soon. In this slide you have my email, and if you have any questions, just write me. I will respond happily. Thank you.